Hello. So now we are coming to the next video. Already we have explained you the theory related to the equation of plane, three equations. Now actually I told you in the last video that I would continue with problems in the next video, but I think let me finish with the theory first, then in the same go we'll finish with the problems. So next one more form is there of plane, that is very easy. In fact, that is a intercept form, right? So first let me explain that, and then the rest of the theory will proceed further. So it's a very small part, so directly I'll go to the plane equation, right? So just you see, if these are the three coordinate axes and I get 3 points, say this was x-axis, so I consider a point A00. Then here it is y-axis, we will consider a point 0B0, and this is a point 0C. What I mean to say is that I am going to consider a point at a distance a unit from the origin in x-axis, b unit along y-axis, and c unit distance along z-axis. So in that case, I will be getting a plane passing through the 3 points, right? So it is not possible to show here. I did not bring the model today of this, so anyway you will be able to understand. So this is just, these are the lines, right, where the plane intersects the coordinate planes, right? Otherwise this is indefinitely extended, this plane. So in that case, what is the equation of this particular plane? So it will be x by a plus y by b z by c equal to 1. I will not go for the deduction, right? This is the equation in intercept form, where very clearly you note it, a is the distance of the point at which the plane cuts x-axis, b is the distance of the point where the plane cuts y-axis, and c is the distance of the point where the plane cuts z-axis. So in that way we get the equation as x by a plus y by b plus z by c equal to 1. So just try to find a link between this. If the points are a00, 0b0, 00c, then these respective coordinates will come down below the respective variables. And in the reverse way also you try to remember, if x by 3, y by 4 and z by 5 would have come, your points would have been 3, 0, 0, 0, 4, 0 and 0, 0, c, like this, right? This is a very easy form, so I am not taking much time for explaining this. So just try to understand that it is very important, in the sense that looking at this plane you can find exactly what are the intercepts on the axis and at what point it intersects the axis, right? So now next we are going to come to define something called family of planes, right? Family of planes, very important concept, family of planes. Now before I go for writing anything, let me just show you a small visual aid. Of course I will not show you the deductions here. For if you are interested, go through the book, and if you find any problem then ask, right? So I'll just show you what situation will it represent. Supposing these two are the planes, right? You have the plane, right? Now if, okay, this plane might intersect or may not intersect also, right? They may intersect, they may not intersect. Supposing that they intersects, then what happens? So just see the situation. Suppose the planes are intersecting each other, right? Like this, one plane, right? One plane, this plane is passing through this, so they are intersecting each other. Now what happens if two planes intersects? There will be a line, right? Two planes always intersects in a single line. This is a line. Okay, now by the word family of planes, what we are going to mean is that after getting this particular intersection, right? After getting this particular intersection, if now I ask you, how many planes you can draw through this line, particularly this line, right? So you can draw how many? Let us just see by inserting one plane here like this. So passing through that line, there may be one plane like this, right? This may be a plane, this may be a plane, right? This may be a plane like this. Now it's not that only that plane will be there, you may be getting another plane over here like this, right? So how many planes like this you can draw? I have only shown you two planes which is passing through the line of intersection of the two given planes. So you can get many infinite number of planes passing through that line of intersection, right? So we are going to talk about the equation of each of those planes, right? And as they are decided by the original two planes, so we call that as family of planes, right? Decided by that two given planes, right? So I'll just transcript this figure in the board also. Suppose this is one plane, I'll draw half of them, right, so that the figure will be clear. And this is another plane, they are intersecting at this line, they are intersecting at this line. So now through this line I can draw another plane, right? I can in fact draw one more plane like this, right? I did not show the below part. So now I have shown you two planes like the model I have shown. I want to decide what are the equation of these particular planes, right? So the first equation we will consider as r dot n1 equal to d1. This equation, second plane equation, we will consider as r dot n2 d2. Then we would now like to find the equation of all these planes. This is 1, suppose this is 2, these equations I need to find. So that will be given by r dot n1 plus lambda times n2 is equal to d1 plus lambda times d2, right? So here this is the equation of family of planes, right? Family of planes passing through the line of intersection of two given planes, right? Whatever are the given planes, already we have written it. So if you need to find now, this is the equation. Now here you see there is a scalar, I did not write it here. Lambda is a scalar, it's a scalar, that is a real number. Now if you go on replacing the value of this lambda, say sometimes 1, sometimes 2, sometimes root 3, anything it can be, every time you replace any value of lambda, you will be going to get equation of each of those planes which are passing through this, right? So this is the equation you have to remember, right? Next, if I would like to convert this into Cartesian, how will you do it, right? So again, this equivalence I will consider as a1x plus b1y plus c1z equal to d1. This one in Cartesian I will consider as a2x plus b2y plus c2z equal to d2, right? In that case, simply if you replace all these value here by converting into vector form, then ultimately this will take what shape? You see, I am writing it here. It is a1x plus b1y plus c1z, right? Then bracket close, then this lambda times a2x plus b2y plus c2z equal to d1 plus lambda d2, right? This is the equation. This is the equation. I am not writing very formally. Please manage it. It's not a difficult one. Because of that, I am not giving very big importance here. But of course, this is an important concept. Now, somebody might reduce this like this also, that a1 plus lambda a2 whole into x, right? What I mean to say is that someone might write this equation as a1 plus lambda a2 x, then b1 plus lambda b2 y then C1 plus lambda C2 Z equal to D plus D1 plus lambda D2. If you would like to write, you can write this also, there is no problem. Actually these are very much same, right? But now there is a question, right? It should be coming to your mind also. We have written n1 plus lambda times n2. Can it happen that it should be n2 plus lambda n1 and this is d2 plus lambda d1? Yes, it can happen. Why can't it happen, right? It can happen. It can happen. That means, see, it's our idea that we are considering this as the first plane, this is the second plane. What if I get it reversed, right? So there is no hard and fast rule that you have to put always lambda to n2, because n2 is being defined by you only, right? So there is no question, you should not be in doubt, right? Only thing you have to remember that if you multiply lambda to n2, then this lambda must be multiplied to the corresponding d2, right? You should not interchange there, otherwise it will be wrong. So this is the concept of family of planes. Now I'm going for the next part, right? These two equations you always remember. We'll be taking problems, as I told you. 2 separate videos will make for only solving the problems with all different levels, right? So that you will not face any problem in future. So I'm closing this now. I'm going for the other part. Okay, now let's talk about the angle between two planes, right? Angle between two planes. Angle between two planes, right? We have to talk about the angle between two planes. This is a very important concept. So I'll show you a model for that, 3-dimensional model, so that you can easily comprehend. Okay, so now just always remember, once you imagine a plane, what should come to your mind first thing? First, just try to recall, whenever you are talking about a plane, always, right, moment you talk about a plane, always what should come to your mind? That with respect to that plane, there is a normal, right? There is a normal to the plane. If I am talking about this plane, so I cannot think about this plane without this particular normal. This plane is being represented by this normal. That A, B, C or that L, M, N are the direction ratios or direction cosines of this line, right? This vector which is perpendicular to it. So whenever we'll be talking about the angles, we'll take the help of this. Let's see how. Okay, first we'll see that. First thing, these are the two planes, right, whose equation I'm going to find. Whose angle I'm going to find. Suppose these two planes are inclined in this way, right? These are inclined. Now can you see one very important thing, that these planes are making two angles with each other. One is this one, another is this side. Now if you find this side angle, is it not possible after that to find this angle directly? It is just the supplement, 180 minus this angle. Or if you find this angle, then 180 minus this, that one is giving you this, right? So why don't you find the acute angle? If I find the acute angle, first define only, then I can find the obtuse angle. And for acute angle, you remember, if I use a cos theta expression, I should get everything positive, right? That's what the trick is. Now why I am bringing this concept, now it will be clear, right? So this is the plane, as I told you. If this is the plane, you have to think about the normal to the plane. This is the normal to the plane, right? Okay, this is the another plane. So when you are thinking about the another plane, there should be a normal to it. This is a normal to it, right? And now suppose you are going to find the angle between these two planes. See, I am not considering this part this time. If I find this angle, automatically this will be found, and if I find this angle, automatically this will be found. Did you get me? So now if I want to find this particular angle, just you see the figure, these two normals and the lines, if I join here, you can see here this foot, if I arrange in such a way that I can join them, then will I get a cyclic quadrilateral here? Can you visualize that? It is cyclic. Why I say cyclic? Because this is 90-degree angle, this is 90-degree angle. So opposite angle of cyclic quadrilaterals are supplementary. Remember that? Or in the reverse direction, in a quadrilateral, if both the opposite pairs of angles are supplementary, then it is a cyclic quadrilateral. So in that sense, it is cyclic. So okay, very nice, cyclic quadrilateral. Now see from that, do not see the three-dimensional way, see the quadrilateral only. This is the side. If I extend it like this, that means this plane, if I extend like this will be an exterior angle, right? This will be an exterior angle. If I hold it like this, right, I think you can easily now see, then there will be an exterior angle produced. Now try to remember, in case of cyclic quadrilateral, exterior angle is equal to the remote interior angle, interior opposite angle, this one, right? So now just you tell me, can you find this angle? You can find this angle very easily, because this is the angle between the normals. Suppose this is n1 and this is n2. So these two vectors, angle you can find. If this angle is found, indirectly you are finding this angle outside, right? Okay, it's all the same. If it becomes like this angle is obtuse, so we get the obtuse angle outside, right? And if we want to produce it for positive values, then it will be the obtuse acute angle, which directly I'll get. Did you understand? So in other words, ultimate conclusion is that if you would like to find the angle between the planes, you need to find the angle between the normals, right? So that's what. Now you need not remember anything, right? So I'll not draw this figure, right? Already this is there in the book, right? Or what do you say? Let me draw it. No, why I'll again just leave this last part. Already we have done so much of things. So these are the planes. This is one normal, say n1, and this is the another normal, say n2, and then we have joined these two. As I told you, this angle I consider this angle as theta. In that case, when I extend this back side, then this is theta, right? Now you can easily observe. Right? So this is theta. So if I find this angle, that means I am finding the angle between the planes, right? So that's all. So it's all the same to find the angle between the planes, means finding the angle between n1 and n2. So if your planes equations are r dot n1 equal to d1, so and r dot n2 equal to d2, so what will be the angle expression for it? Cos theta. Angle between whom? n1 and n2. This thing divided by magnitude of n1, magnitude of n2. If you want, you can leave this here only, right? But as I talk about the acute angle, right? Supposing that you are always interested in the acute angle, so you put a modulus here, right? But you must mention here theta is acute, right? So choice is yours. And now this you can easily convert. In between, let me just try to tell you. Do you need to remember anything else? If you remember the angle between two vectors, nothing, right? So now if you convert these two into your Cartesian equation, right? Cartesian equivalent, if you do, then just I am asking you, what you will say about n1 and n2, right? Their components are whom? Which are the components of this n1 and n2? a1, b1, c1, they are the components of n1. a2, b2, c2 are the components of n2. So dot product will be what? Simply, if I write in terms of components, I will be getting a1, a2, b1, b2, c1, c2, and magnitude of n1 will be what? a1 square, b1 square, c1 square, another root, and this is a2 square plus b2 square plus c2 square, and there is a modulus. Again I am saying that we are confining ourselves up to the acute angle, that's all, right? So here it is the angle between two planes, and this is the expression. Take little time, see this figure also, replay the video, see the original inclination of the models, and then you try to identify that. You will be able to do it very clearly, there is no doubt about that, right? Now just a particular case, right, which I will not write here, just you will be able to remember. Suppose the planes are parallel. Condition of parallelism I am talking about. These are the parallel planes. What can you see? If the planes are parallel, the normals are also parallel. That is, n1 is parallel to n2. n1 is parallel to n2. If n1 is parallel to n2, what you will observe? n1 can be expressed as some scalar times n2, right? Understood? It means when you will find the planes, you will simply find that if there is a vector n, one in the first plane and the other is parallel to it, these vectors will be simply obtained from n1 just by multiplying a number or by dividing with a non-zero number, right? That's all. And if you look at this Cartesian ones, what you will find? a1 b1 c1 a2 b2 c2, these will be proportional, means by a fixed number all these will be multiplied and these will be obtained, right? That is the condition of parallelism, right? So that I will not write. And then if you talk about perpendicularity, what you will observe? Again the same thing, n1 perpendicular to n2. Now when two vectors are perpendicular, if dot product is 0, that means these two planes will be perpendicular if n1 dot n2 equal to 0. That means in Cartesian or component wise expression, a1 a2 plus b1 b2 plus c1 c2 will be 0, right? So overall sum up in Cartesian or say component form, if this quantity is 0, planes are perpendicular. If these a1 a2 b1 b2 c1 c2 ratios are same, planes are parallel. That's it, right? So we'll be going for the another part now. Okay, so now we'll be talking about the next topic, right? That is perpendicular distance of a point from a plane, right? So here also I will not show you the deductions, directly we will go for the formula and it's enough to know, right? So just you see this be the plane, and somewhere suppose there is a point whose coordinates I would like to write as x1, y1, z1. So if I drop a perpendicular, then this particular length I want to find, right? And equation of the plane be suppose ax plus by plus cz equal to d. Then this perpendicular distance, suppose this I name it as m. So what is pm expression will be? It is very simple, try to remember it, very simple. These coordinates you replace here, right? And you write it, right? ax1 plus by1 plus cz1, and whatever is in the right side, remember it, in this case right side should be made 0, so you bring to the left side and put a modulus region, it should not be negative, and below just the square, sum of the squares of these coefficients under the rule. So this is the formula, this which you can easily remember. Actually this is if you remember your class 11, in class 11 we got distance of a point from the line, same, only thing is that one coordinate has been increased, therefore c square has been increased, cz1 has been increased, otherwise it's all the same, right? So this is the formula, working formula for finding the distance of a point from the given plane, and Cartesian is enough, right? Now we'll be going to the next one, that is angle between a line and a plane. Angle between a line and a plane. Angle between a line and a plane. So simple. I'll be again bringing that small aid so that you can visualize, right? So suppose this with a plane, and already I told you, make it a habit when you see a plane, always you should see the perpendicular, right? This with a plane and this with a line. This is a line, right? So I want to find the angle made by this line with the plane. So how many angles are there? You can see one is this side, right? If I hold it like this, this is one angle and this is the another angle. Now if the line is like this, okay, so what I am going to do is this. You see, either the line I can shift parallelly here, right, only to find the angle, right, remember it, or this perpendicular I can shift and I'll make this particular foot match together. So now if somebody is asking about this angle, right, I am holding it in front of you directly so that you can easily compare. If someone is asking about this angle, right, this angle they are talking about, why don't you find this angle? If you find this angle, then it is the 90 degree minus theta, right? Or if you find, if you consider this angle, this is 90 minus theta. You got it? So because why I am saying it is easy to find the angle between these two, because this is N1 and if this is the line, then it is parallel to whom? It is parallel to some vector B1. So simply B1 and N1, find the angle and take the supplement of it, right? So this is what we are going to use for the deduction of the expression, right? So you see, this is the plane, right? We are talking about the normal. This is N1 or N, and this is the line. Somehow we made it just through this point, just for deducting the formula. So now I am supposed to find this angle. If this is theta, what we have decided this as, it is 90 minus theta, and 90 minus theta is the angle between whom? This line and N. This line is parallel to whom? Some vector B, right? So it's all the same to find the angle between N and the vector B, right? And then automatically you will be getting the angle theta just by taking the supplement, right? So, but while doing the deduction, we'll get the expression directly. How? See, our plane, first we'll consider the plane. This is the plane, right? This is the plane where N1 is here, and a line I should consider R equal to A1 plus lambda B1 is the line, or rather I write A plus lambda B, right? So this is the vector, this is the line, this is the vector to which the line is parallel. So now we have seen here that angle theta is the angle between the plane and the line. So what is the angle between the N and the line? It's 90 minus theta. So cos of 90 minus theta, that is angle between the vector N and vector B. How do you find that? Dot product, right? In the numerator, what you will find? Dot product of these two vectors, this and B, or B dot N, and their magnitude. And in the left side, cos of 90 minus theta will become sin theta, right? So you can express this directly in terms of theta. So this is what giving you the angle between a line and a plane, right? It's a very easy concept. So actually you have come to the end of the theory part. Just one very important part, purposely I kept till the last, because I need to explain a little more for that. I can directly tell you that remember the formula, but why it comes I am showing you. Many of the times I have skipped many formula or many deductions, but you will be able to do that, or that is not very important to visualize, so I skipped it. But this is very important to note, because there is a confusion coming among, right? Because of that I am saying it is about a coplanarity of two lines. Coplanarity of two lines. Remember it. Because why and where confusion comes, I am going to explain you that also. Right? First, let me write the heading. What is the heading? It is coplanarity of two lines. That means under what conditions two lines will be coplanar. This one and these two. This one and this one. Two lines are there. Under what conditions they will be coplanar? Coplanar means lying in the same plane, right? Now, coplanarity of vector and coplanarity of line, there is a vast difference. We always get confused. If I am talking about two vectors, they are always coplanar. But if I am talking about two directed lines in space, they are not always coplanar. What is the condition to be satisfied? Remember, this difference I would like to show you by the physical interpretation so that you will be able to understand this, right? So first of all, I am going to show you why we can have two coplanar vectors, right? This is one vector, this is another vector, right? Like this I am rotating, so there is no link, but still they are coplanar. How? Because we know that vectors can be shifted parallelly. Actually, we are doing all the jobs for free vectors. So any one of the vector you fix and the other one you transfer it in such a way that it will be meeting with the initial point. And now you can see that there can be a plane. They can be lying in the plane. So whether they are here or here. Now eventually you will ask me a question, why then line cannot be? It is here, I can shift it, so it will be coplanar. There is the main part line, right? You cannot shift a line. Why? Because line has different specifications. What? See the equation. A1 dot lambda B1. For a moment lambda B1 ko goli marte hai, right? A1 means what? This is the line. If I consider this is the first line, this is the first line passing through some point, say A here, right? A1 here, and it is parallel to some other vector. Now think, if I am told to shift this line like this, what is the thing we missed? If I shift the line somewhere like this parallelly, I have missed a thing. What is the thing I missed? This point. Because this point I cannot shift. It has a very important position. That means if I shift it, only direction I have changed, I could not bring this line, right? So it is still lying there. So two lines will be coplanar only if they will strictly lie in the same plane in their position itself, right? So there is a difference between the vectors coplanarity, right, and lines coplanarity. So here these two are coplanar, means they are lying in the same plane, and under what condition will they lie? First I am giving you the memory aid, then I will show you the small deductions. Memory aid is simple. Whatever was the numerator of shortest distance formula, equate it to 0, right? What was the numerator? It is A2 minus A1 dot B1 cross B2 will be 0, right? So you are done. So numerator of the shortest distance formula equated to 0 gives you the condition for coplanarity. I am giving you just a memory to remember. Now I will show you how it becomes, right? How it becomes like this. Okay. So for that I am taking two lines. Then it will be easy for you to visualize. These are the two lines, right? These are the two lines lying in this plane. Okay. Now why that condition prevails, I am going to tell you that. This is going to pass through some point A. Suppose A is here. This is going to pass through some point A2. A2 is here. A1, A2 is here. If I join them, this line segment is entirely lying in this plane. Fine. Then this direction is B1, this direction is B2. I take the cross product of B1, B2. I'll get a line perpendicular to it. So if this line is perpendicular to this plane, will it not be perpendicular to A2 minus A1? If they are coplanar, remember it, if they are coplanar. If not, this condition will not be there. Because they are coplanar, if B1 cross B2 is perpendicular, it has to be perpendicular to this particular point, particular line, that is A2 minus A1. So if two vectors are perpendicular, dot product is 0. So that's what we have got here as the required condition. And now if you want, you can convert this into Cartesian. Cartesian means what? It is again the numerator, Cartesian, that numerator, determinant one of the shorter distance. So it's all about 3D, right? So here, so far we have finished with all the three parts, leaving some of the deductions which I did not feel very important to give explanation. Now if instead you feel that no, we want to know it, please write in the comment box or inform me personally. I'll do that. But now as we have finished with the concepts, this is your duty now to go through all the concepts, make it very clear. And then if you follow the next two videos, I'm going to take 2 more videos just to do the important problems, right? Because line problems already we did, plane I did not do. So one plane, not only one plane, both the periods shall be including now problems mixed with planes as well as lines, which are very, very important and exam oriented, right? So I do hope that this is going to help you, and this is my request to you all. Please follow the video in sequence, then you will not be facing any problem, right? So with this today, this particular video I would like to finish with, right? Okay, bye. So see you next day with the problems. Bye.